This week's lab is ruler rotation. In it, you'll hopefully learn how to measure torque, determine rotational inertia, and explore potential errors and solutions in performing this lab. For this lab, we used a tape meter stick, a smartphone, Play-Doh, a ruler with 3 holes, tape, and a wooden rod or dowel, something we can use to hold the ruler up and rotate the ruler around. Before we begin, we again recommend you watch our lab preparation videos over prepping the meter stick, mounting the smartphone, and how to use tracker. As always, we want to prepare the smartphone to take videos and prepare the meter stick. To get started, we want to mount your rod of choice to a flat surface using tape. Then, tape the rod so that the ruler cannot move horizontally. Before we do anything, we want to weigh the ruler. We also want to make sure our rod can fit into the holes of the ruler. Since this rod won't fit in smaller holes, we'll use a smaller rod when needed. For demonstration, we'll keep with the larger rod. First thing we do is tape down the rod to the table. Second, we secure the position of the ruler by taping the rod in front and behind the ruler. So that tracker has an easier time tracking the rotational motion of the ruler, we add 3 circles of Play-Doh to the face of the ruler, covering the holes. Make sure to record the mass of the Play-Doh. Then we can perform the experiment. In the video, we simply roll some small orbs of Play-Doh and place them on the ruler where the holes are. Try to keep the spots as round as possible. Again, we measure the mass of the Play-Doh added. To perform the experiment, we simply lift the ruler to one side and let go of it. Now, we'll make a modification to our ruler. First, remove the Play-Doh from the ruler. Add a large mass of Play-Doh. Make sure to weigh it first before placing it on the ruler. Then, add a smaller piece of Play-Doh with contrasting color. This is so tracker has an easier time tracking the motion. Weigh that piece of Play-Doh before adding as well. In our experiment, we weigh a larger mass of Play-Doh before securing it to the ruler. Then, we weigh a small orange dot of Play-Doh and add it to our purple mass. Finally, we adjust the location of the mass, then perform the experiment. With that, we can move on to tracker analysis. For tracker, we load our video in and then set up the calibration stick. Then we set a coordinate system near the top of the ruler at the axis of rotation. We also slightly rotate the coordinate system to match the orientation of the length scale. Next, we select our frames of interest as always. Next, we'll set up our auto tracker. We increase the tether so tracker has more leeway when finding the Play-Doh. We set up a second auto tracker for the second dot of Play-Doh. We can change the axis of these graphs to variables we are more interested in, like rotational angle and angular velocity. We then repeat this process for the last few dots of Play-Doh. Sometimes, tracker fails to have a match score, and that's fine if it happens a few times. If it just keeps happening, change the template. When we look at the graph of the last piece of Play-Doh, we see a noisy spot here in our angular acceleration graph. This is where tracker had a hard time finding the center of the object. You can compare the different mass on the graph as well. We can also switch which variables are displayed in our tables. Finally, when you finish, you can save your data. Some potential sources of error include the ruler not being secured on the rod or the smartphone not being mounted correctly. A potential issue in video analysis could come from the contrasting Play-Doh not being added to the ruler. That'll be all for this week's lab. As always, if you have any questions, please ask your TA or professor.